$20. If I were to drop the price, what happens to my total revenue?
14.
Goes up, doesn't it? If I drop the price then to $6, what's my total revenue? 18. If I drop the price to $5, what's my total revenue? It's 20, isn't it? Is it rising in the elastic section of the demand function? When I drop the price then to $4, what is my total revenue?
20.
20. Now do you understand why that's the section that's unit elastic? You understand that? It doesn't matter if I raise the price or lower the price, is my total revenue the same? It's 20. So thus, the change in P, now come on you guys, you know math, the change in P and change in Q over its midpoint, isn't it going to give us ultimately a PED of 1? Correct? But notice what happens to your revenues now when you cut then prices in the inelastic area. So we were at 4 times 5, a total revenue of $20, and when we cut our price now, what happens to our total revenue? Goes down. And when we cut it again, it'll continue to go down, won't it? Now I know it's pretty straightforward here, so you gotta trust me, we're gonna use this again later. All right, we really are, you guys. Oops, do I have this set up on a? No, I don't. I gotta walk over here all the time. So once again, here's how they show it to students using slope. All right, that's really what I wanted on your extra credit. Using the concept of elasticity, when are coupons effective? See the concept of elasticity. All right, they would be most effective when the demand is what? Elastic. If you drew a picture using slope, not a linear function in math. Does that make sense now? All right, so I wanted to make sure that you knew that. That is going to be very important. Keep in mind, sometimes they're going to throw some graphs at you, and they might represent, a question about what does this mean. They may have this on the left, and then, well, what does this mean? Well, this is just showing you total revenue, all right? That's all it's showing. As I cut prices, my revenue rises until some point I cut prices in the elastic range, and then inelastic range it's going to fall. So you guys can certainly look through this, all right? All the notes are going to be on there for you, not very hard. I think the thing that and I've got some really nice, that's not dark enough, you guys, sorry. I've got some really nice graphs set up here for you with all of the rules. All right, I'm going to give you a printout of all of this as well, so you have kind of a little cheat sheet. I've got something I'm putting together right now. Now that's price elasticity of demand. All right, if we go down here, all right, and you know the importance of all this. Firms are going to price discriminate based upon elasticity. All right, let's all be smart here now, okay? Could you actually increase your revenue by cutting the prices for senior citizens? What is their demand to go to a movie? Is it more elastic or inelastic? It's more elastic. Do you get it now? You would want to then, you could actually lower the prices and bring in more revenue. They're pretty responsive to price changes, aren't they? All right, but kids are more inelastic. How about this? What is the demand for going to see a movie, all right, on Tuesday nights? Is it more elastic or inelastic versus a Friday night? It's more elastic, isn't it? Do you see now why they have $5 Tuesday night? You could actually lower the price, all right, and you could bring in more revenue. That's why they price discriminate sometimes, and they charge people different prices, you guys. All right, so does that make sense? They're really looking at each individual's elasticity function, and they could actually bring in more revenue. Now you see why what I showed you here earlier is really important. All right, does that make sense then? And I don't know why, all right, the infant is going to the R-rated movie. Okay, but, all right, still $10. That was supposed to be funny. Okay, okay, so let's get rid of that. We already did this. You know, taxation, we talked about it a little bit, but you'll notice you could have questions like this. When would it be a best option for government then? Where could they bring in the most revenue? Okay, when we look at this right here, okay, if it's more elastic and they raise the price, all right, and they increase taxation versus if the demand is highly inelastic and they increase taxation. Do you see how that would impact then the revenue that they're bringing into the government? So these are real easy. You know, try not to get the easy ones incorrect. Drugs, I can do that. Subsidies, you guys should be able to handle that. There's Benny Boy, this is some of the stuff we looked at in class. But what I need to get you to is right here. Okay, so this is PED. Then we need to look at XED. Now that represents what's called cross-elasticity of demand. Okay, PED, XED. I'm going to use the midpoint formula again, but rather than looking at, all right, an increase in the price, let's put mac and cheese up here, okay, and then what impact it has on QD. What we're doing now is we're going to, let's throw this over here, mac and cheese that's Food Club. Now we're going to look at a change in price of Kraft and what happens to the demand for this product. See, you're crossing two products now. Does that make sense? PED, price of this rises, what happens to quantity demanded? Here, cross elasticity, raise the price of Kraft. Let's try that once. I'm going to put two demand functions up here. Okay, this is going to be Kraft, and I'll just do something like this, okay? And we will increase the price of Kraft. Let's do $1, all right, to $2. Let's just do that. Okay? Then what we're going to measure is what happens then to the demand. D1, okay? I'm going to put Food Club here. Food Club. That's cross-elasticity. So what you're really measuring is what? The change in Q of what? Food Club over the change in P of what? Kraft. Now, do you remember over here I said you could ignore any negative values? We were just going to look at absolute values. It doesn't matter, all right? It would, you fathead. It wouldn't matter, you guys, if price was going up or down, okay? It's still going to have the same effect on Q. So all you have to just ignore all negatives here. Okay? Doesn't matter. That is not the case here. You must take into consideration negative values. You have to, or you're going to get the question wrong. Values, okay? You have to. And here's going to be how easy this is. Most of the questions, all right, it's not about even the math. It's about whether or not you can indicate if it's a complement or a substitute. Okay, so now let's try this once. We're going to increase the price of Kraft. So our new price is 2. 2 minus 1, does that give us a positive value?
Yes.
When we increase our price here? So I'm going to put a plus here. Okay? If I increase the price of Kraft, what's going to happen to the demand for Food Club? Which way do you want me to shift the demand function? To the right, very good. I'm going to put D2. And we're going to pick a price, all right, now at $2. Okay? So what happened to the quantity demanded, Q1 to Q2? Is this a positive value or a negative value?
Positive.
Without doing any math, is it positive or negative?
Positive.
It's positive. So what I'm gonna do here now, so I had this change in price is positive, this change in Q for food club, all right, food club, this is a positive value as well. So when the change in Q over the change in P is a positive value, what does that tell us that these two are? Substitutes. That's what it's gonna be. No, that's not hard, is it? But if you don't know the dang thing, you're gonna get wrong in the test.
So it doesn't really matter about the number, just you need to know. if it's
Well,
positive
most of
or
the
negative.
time, Pop, now remember, it's a time test, you can't use a calculator. So that's what's beautiful about this, and there's no essay part. Are you gonna be inundated with doing a lot of hard math? Never. Even the AP test, there is no calculator. It's not about the math, it's about knowing, you know, what Sam Hill you're doing it. So you can imagine now, let's try something else. Let's, what do I have a product in here that, okay, this is this is milk. Alright, milk. And we're gonna see an increase in the price of milk. What will happen to the demand for Food Club? It's gonna decrease, isn't it? So now, we would have, I'll just draw this as D3, is that okay? D3. So now we would be moving from Q1 to what? To Q3, wouldn't we? So that would be well, what value?
Negative.
A negative value. So then, let's try that once, I'll put the change in Q of Food Club, and you said that's a negative value, over, it's always change in Q over change in P, all right, of milk, then that is a what value?
Positive.
But what is our net value? Is a negative value, correct? And so then negative values always represent a what?
Complement.
A complement. Now, if they have a question about this, okay, this would be probably AP, but what if your value, all right, is greater than 1? Or greater than -1? We usually call those strong complements or strong substitutes. It's generally when the value is greater than 1. Okay, does that make sense now? I don't know if you'll run into that. You know. So that's cross-elasticity of demand. The last thing that we're going to, you know what, one last thing, you guys. I showed you how to do all of that, all right? Notice I just showed you how to do all that. That's this right here, okay? What if you have, I want you to think about this. What if you have, I got an idea here. Milk is rising in prices, okay? And I'm gonna put over here now, I gotta get my rate, you guys. Milk is rising in prices. This happened one time on an AP test. Lead sinkers. There's your demand function. What will happen to the demand for lead sinkers if milk rises?
Nothing.
Nothing. So your change in Q would be what?
0.
0. So if you have a cross-elasticity of demand of 0, what does that tell you?
No relationship
No
between the two.
relationship. 0 divided by anything is 0, right? So, yeah, all right, so make sure you understand that. The last thing, and notice you guys, I have all of this for you here, once again in your charts. The last thing that we want to look at is income elasticity of demand. All right? This is cross, this is price elasticity of demand. This is going to be called income elasticity of demand. Do you see why you have to kind of know what these terms mean? Okay. What did you guys do in class? You just did this. You just looked at the responsiveness to a price change for that product. We're comparing. And the last thing, we're still comparing here, but what are we comparing to? Your income changes. So let's do the same thing as this. Okay? This is called income. I should have put that up here. This is cross elasticity. This is price elasticity. All right? And this is income. All right? Elasticity of demand. Income. So let's try that once. Let's look at a change in Q. Change in Q of, okay, steak. We're going to look at, here's what we're going to do. We're going to look at a change in your income. Your income went up from $100 a week to $200 a week. Positive value or negative?
Positive.
Once again, probably not going to have to do the math. This is a positive value. If I drew this little graph over here and I put steak, here's your demand function. What do you expect to happen to the demand for steak? D2. The change in Q, will that be positive or negative?
Positive.
That's positive because we can pick any price point here and we're moving away. We're going from Q1 to Q2. That's a positive value. So I'm going to put just up here, I'm going to put a little positive here, okay? And our change in income. And we said that that was what? It was rising. So that was a positive value. So what is our net result?
Positive.
Positive. When it's a positive value, what does that tell us about what type of good it is? Very good. It's a normal good, isn't it? Isn't that what we said in class? If our incomes rise and we see an increase for the product, isn't that a normal good? What do you think a negative value is going to represent then? An inferior good. Okay? Fair enough? Let's get rid of this then. I'm going to go back. All right, now what we're going to do, and I'm serious now, make sure that you do a good job with consumption theory, and it's not very hard. I don't have a lot of notes here for you, and like I said, I think it was Benny in the Jet said he had 5 questions on his exam that were all related to consumer choice and consumption bundles. All right, so here's what we're going to do. If you recall in class, I had said, I think it was something like this. I had apples and oranges, okay? Isn't that what we said in class? And, you know, what's the opportunity cost of purchasing an apple? Well, it's the value of what we give up. I'm going to change something today. What if I said you had $20 in your pocket? You got 20 bucks, okay? And you're going to use that $20 to buy apples and oranges. How many apples should you buy and how many oranges should you buy? That's what you're doing here. How would a rational person do this? How would they do that? Okay, so watch here now once. Are we all in agreement that you know what utiles are? Remember what utility is? What's the word utility mean?
Satisfaction.
Very good. Diminishing marginal utility. Utility is the amount of satisfaction we get from each, all right, consumption. When I eat the first donut right here, thanks, Petro. No free goods, so I'll trade you. Man, that was good. With each additional consumption, what will happen to my utility? Well, okay, we're going to get that out of the way. You will notice now, okay, this graph right here is measuring total utility or utiles received from each consumption. Is there any way that I can blow this up? Right here, can you see that a little bit better now?
Mhm.
How about like that?
Oh, yeah.
Okay. So you're gonna notice this is just measuring total utility. With our first consumption, we would get 15 utiles. With our second consumption, all right, it looks to me like we have, my eyes are so bad. With our, it'll show us right here. With our first consumption, 15 utiles. With our second consumption, is that 28? So notice with each consumption is our marginal utility falling. Marginal is how much utility with each consumption. Okay. Now, you're gonna notice that this then measures marginal utility, this nice straight line. This is total utility. And what we're gonna do then, right, and notice that, Kyle, our utility even went negative when we had the 9th clam. We're gonna have clams and potatoes here. How can you have negative utility? Yeah, you start to barf. It comes back up. All right. So what we're gonna add to this now is what? A budget constraint. Now I talked about this in class a little bit earlier when we were looking at PPF models, you guys. All right? Let's try this again then. A PPF model, I said don't get too confused here. A lot of times you'll have a budget constraint question, you guys. You will. Just an easy budget constraint question. All right, a real easy one. Now on its surface, this looks like a what? A PPF model with a nice straight line, doesn't it? Guns and butter. You know, we could produce 8 of them, all right, or 10 of these, and we'd have to make choices. Well, we add something to that, all right? Today it could be clams and potatoes. If I said you had $100 in your pocket, all right, and if you put all of your $100 into guns, and you could purchase, all right, 20 of them. What does that tell you about the price then of guns?
$5.
How much? $5. That's what we were saying here. And how about 10 units of butter?
Or $10.
$10, right, per unit of butter. That's what a budget constraint is. That's all it is. And if you then were to what? Buy some butter. You'd have to give up some guns, wouldn't you? Based upon how much money you have. So that's all you're doing here. This then represents, you're gonna notice with clams and potatoes, all right, I believe that we are assuming your income is $20 here. 20 bucks. So if you could buy 10 units of potatoes, how much do they cost per pound? $2, don't they? If you can buy 5 units of clams, what would it be? $4. I'm asking you, how many potatoes and how many clams should you then buy? How are you going to maximize your benefits? Okay, so here's how we're going to do this. Okay. We can do the total utility test. You could do that. Okay, you could do that. Now notice my question, why is 10 units of potatoes and 5 units of clams not achievable? Where would you maximize your utility? Is if you bought what? 5 units of clams, that would be total utility, right? Can you guys see marginal utility here? Your first unit of clams, 15. Your second unit of clams, your total utility is what? 25, but what's your marginal?
10.
10. You get it? You get it? Okay. So if I wanted to maximize my utility, wouldn't I just buy 5 clams and 10, all right, 10 units of potatoes? Wouldn't I do that? The only problem is you're limited by what?
20 bucks.
You got 20 bucks. You don't have enough money. You're gonna have to buy a combination or two. Okay? And that's what I put. This gives us total utility. All right? Where would our total utility be maximized? Given what? That you have 20 bucks. Right? wanna look at the marginal utility per dollar? I want you to think about that. So I can have a potato or I can have a clam. What is my marginal utility when I consume the first clam? It was $15, wasn't it? But what is my marginal utility per dollar? Wouldn't I take 15 and divide by 4? Is everybody, you clear on that? Okay. What is my marginal utility per dollar? All right, with potatoes, my first choice. Well, there's my marginal utility. If I divide that by 2, it's 5.75. So you tell me now, that's all I want you to tell me. Should that first item that I'm gonna buy, I got 20 bucks in my pocket, that first item that I buy, should it be a clam or a potato? What would you guys, where would you maximize
Would Haley
your
Farnham,
benefits?
Tasha
What do you
Page,
think?
Haley Sequin,
I would
Hayden
go for a tater,
McGinnis,
right?
come to
Shows
the
me.
office.
Holy crap, my marginal utility
Also
per
Taylor
dollar is
Wilkinson.
5.75. Well, what did we burn up then? What did we just burn up? I think we burnt up $2, right? I'm gonna put that on the side. What should we choose next? Another potato, or should we go with the dang clam?
Another tato.
I go with the tater, $2. How about our next choice?
Another tater.
Looks like another tater.
Clam.
Looks like now maybe we should go get a clam. So I'm gonna put, how much are we spending here? $4. Now what have we spent so far?
10.
2, 4, 6, we spent $10. We got some money to spend. What should we go with next?
Tater.
We're gonna go here with our tater, $2. What next?
Tater.
I think another tater, right? 2, 4, 6, 8, 10, $14. What should we go next? Looks to me like a clam. Now we're up to $18, right?
Tater.
And then I think we should go with the tater. Have we burnt up all 20 of our dollars?
Yes.
You should buy 2 clams and 6 taters. Okay? Now the rule that we have for this is right here. This is the margin utility maximization rule, where the margin utility of one product divided by its price is equal to the marginal utility of the other product by its price. And you're gonna notice when you look at your graph here, okay, our marginal utility divided by its price is 5.75, okay? All right, we should do this in units of 2, because that's how our graph is set up, okay? If we could
Would Haley
buy
Farnham,
2 of
Tasha
these,
Page, Haley Sequin, Hayden
we burnt up
McGinnis, come to the
$4.
office.
That means we have $16 to spend, all right, on clams, all right? And that would be 4 of them. But our marginal utility per dollar when we buy 4 clams, all right, you're gonna notice is 0.75. Well, that's greater than that. So then when I move to 4 units, it's $3.50, all right? It's still greater than $3.75. When I move then 2 more units, $2.25 is greater than this. When I move 2 more units, now we're almost in equilibrium. That's really what you're doing there. Okay? Marginal utility divided by its price of one product equal to the other. A lot of times you guys, they'll have it set up like this too. All right, so now you know how to do it, right? Thank you. Tomorrow, I'm gonna start some stuff with pure competition.